Another unit of concentration that is used quite a bit in chemistry is molarity, and its shorthand symbol is big M. This is also called molar concentration. And here's the formula for it. So molarity is given as the number of moles of my solute, whatever I'm dissolving, divided by the liters of solution. Make sure that that unit is in liters and not milliliters. Here's the sample problem for you to try. Determine the molarity of the following glucose solutions. So all of these are glucose solutions with different concentrations. You can have 0.223 moles of glucose in 1.5 liters of solution, 50 grams of glucose in 2 liters of solution, or 136 grams in 750 milliliters of solution. Obviously, we're going to use this formula. However, you've got to make sure that the units match. So you want moles on top. If you are given grams, you're going to have to convert those into moles. Here's the formula, so you can calculate the molar mass from the periodic table and convert grams to moles. Then you get moles of solute over liters of solution. These two are liters, so this one is in milliliters. I have done the last one for you. So if I take 136 grams of glucose and I multiply it by my conversion factor, which is the molar mass of glucose. 1 mole of glucose weighs 180.16 grams. My grams will cancel, leaving me with moles. So 136 times 1 divided by 180.16 gives me 0.755 moles of glucose. So now that I have the moles of solute, I need to get liters of solution. This is 750 milliliters. And if I convert it to liters, I have to divide it by 1,000. 1 liter has 1,000 milliliters, and so I divide that to give me liters of solution. Now that I have moles and I have liters, I can just go ahead and divide the two to get 0.755 moles of glucose over 0.750 liters of solution gives me 1.01 molar glucose. Give A and B a try. Here's another sample problem. Determine the volume in liters of each solution that contains this many moles of solute. Now we have given the molarity of each solution and the moles of solute. We're asked to figure out liters of solution. So we have molarity, moles over liter. We need to figure out the liters. I can use the molarity in this fashion so the M stands for moles per liter, and I can use this value two different ways. I can use it as 0.0448 moles of Na3PO4 over 1 liter of solution, or I can use 0.0448 moles of Na3PO4 over 1 liter of solution. So I can use this as a conversion factor two different ways depending on what I'm given. In this case, I'm given the moles of my solute. So I start with what I'm given, 0.313 moles of my solute multiplied. Since I want volume, then I will pick this particular conversion factor because I have the volume on top and the moles at the bottom. So multiplied by 1 liter of solution over 0.0448 moles Na3PO4. These moles will cancel out, giving me 0.313 times 1 divided by 0.0448, 6.99 liters of solution. Note that this has 3 significant digits because these have 3 significant digits apiece. Now follow this example to do B and C.